Okay, so end behavior refers to the behavior of a function for very large x values or very large y values, either negative or positive. If you want to think about it geometrically, the x and y axes, they sort of are the only ways to localize your functions. They're infinite to both sides, so they have no end. But if you want to just think about it intuitively, the end being outside of it, there is no outside, like I said, but if there was, there would be a way to get to the end through plus infinity, right? Y is minus infinity here on this bottom. To the left, x is minus infinity. And to the top, y is plus infinity. So there isn't really, so they aren't actually equal to these numbers because infinity is not a number. But in reality, we are just thinking about it intuitively. So this is the idea. Whenever x goes to plus or minus infinity, or y goes to plus or minus infinity, that's end behavior. Because out of the graph, out of the rectangular Cartesian coordinate system, we are talking about the end there. Okay. We already know how to calculate slant asymptotes from pre-calculus, but I'll remind you how to do it. So slant asymptote is just an asymptote that's not a horizontal or vertical asymptote. So we're going to do that now using either the long division or the synthetic division algorithm. Let's start with long division. So looking at the function that I gave as an example, the degree of the top is exactly 1 plus the degree of the bottom is exactly 1 above degree 2 and degree 1. So there is a slant asymptote, and I find it by using long division. Let's do long division like I said. I set it up like that. Put the function here, division symbol, maybe a little lower. This is the divisor, and the top is going to be the result, so I change colors there. So the quotient will be on the top. So I need to find something here that when I multiply by x plus 1, the leading coefficients match. So I need to multiply this by 2x. So when I use the distributive property, I'll get 2x times x, that's 2x squared. And then 2x times 1, that's 2x. I subtract the 2, these two cancel, and this becomes a 4x minus 2. Now I do it again. I got to multiply this by something so that the leading coefficients match. So that's a 4, it's a plus 4. So 4 times x, that's 4x. Those match, that's what I wanted. 4 times 1, that's 4. So I subtract them, and that will be, these two cancel. So that's 0. Minus 6. So that's the remainder. So this is the part that I can't divide further, and that means that this thing, so the result would be the quotient on the top, 2x plus 4, that's the result, quote unquote. But then there's this remainder, which is a part that I couldn't divide further, so that stays on the top of the fraction. So what does that mean? This means that when x becomes larger and larger, this is very close to 0. Regardless of whether x is positive or negative, this approaches 0 when x goes to either plus or minus infinity, doesn't matter. So all that is left is this. And this is the equation of a line 2x plus 4. So y equal to x plus 4 is a slant asymptote of f. Okay, so y equals 2x plus 4 is our answer. So that's how you find slant asymptotes. You don't need any calculus, only to understand that this is going to go to 0, right? 6 minus 6 on the top stays constant, but the bottom gets bigger and bigger. A number divided by something big equals something small, so 0. And this is all that matters. Now at the bottom, you have, I guess, the summary for end behavior for rational functions. So I'll quickly walk you through. So a rational function is a function that's the division of two polynomials. So P and Q are polynomials. We're saying that the degree of the top is m and the degree of the bottom is n. Okay, so this is degree m and this is degree n. So if the degree of the top is smaller, then the bottom is going to grow a lot faster, so the limit will be 0. And therefore, y equals 0 is a horizontal asymptote. And we're talking, of course, about the limit when x goes to plus or minus infinity. If the degrees are equal, we did this before in a separate video, the limit is a real number, which is the ratio between the leading coefficients, right? So it was something like this, the limit, as an example, if you have, I don't know, 6x squared plus 4 over 3x squared plus 1, then this equals 6 over 3, so the two leading coefficients, which is 2, and then that y equals to 2, right, in that case, is our horizontal asymptote. Okay, another case is when m is exactly 1 above n, so the degree of the top is exactly 1 above the degree of the bottom, which is the case we just did for slant asymptotes. So the graph has no horizontal asymptotes, but it does have a slant asymptote that you find using long division or synthetic division. And D is about vertical asymptotes. The vertical asymptotes occur at the zeros of the denominator, but after, and that's important, after we remove common factors. So we need to cancel common factors of P and Q first. However, sometimes these rules altogether are enough, and we just have to resort to calculating the actual limit. So we're going to do an example here where a limit is necessary. These aren't polynomials because of the square root here. So we have to be careful. We have to calculate the limit. So how do we do that? We look at the highest degree at the denominator. So that's x to the 6th. But there is also a root. So we divide the top and the bottom by the root x to the 6th, which could be kind of challenging. So let's do the obvious thing first. So let's see what happens on the right side when x goes to plus infinity. We're going to have 10x cubed minus 3x squared plus 8 over cube root of square root of x to the 6th. Same thing at the bottom. So I'll just put a single, I'll do that later. 1 root for each. So that's the limit when x goes to plus infinity. Okay, so x is positive, right? Because it's going to plus infinity, so it's like positive a million, positive a billion, whatever you want to think about. So the square root of x to the 6th is x cubed. So that's 10x cubed minus 3x squared plus 8 over x cubed. and then divided by, so we can put a single root for each, then have 25x to the 6th plus x to the 4th plus 2 for x to the 6th. And that's going to be my, I guess, second to last step. I'll put 1x cubed for each of those guys. That will give me what I'm looking for. That will give me a chance to cancel the x cubeds here. So that's a 10. And then minus 3 over x plus 8 over x cubed. All that divided by the square root of 25. And then 1 over x squared plus 2 over x to the 6th. And now recall, right? This x is getting bigger and bigger and bigger. This divided by something, 3 divided by something big, that's 0, that's 0, that's 0, and that's 0. All of these are 0. All that's left is 10 over root 25. So that's 10 over 5, which is 2. So cool. This is one of our horizontal asymptotes. I'll write it there, y equal to 2 is a horizontal asymptote. On the other side, and then I'll change colors, we do more or less the same thing, but there is a small complication here. There is a small complication. We're about to solve it. So I start the same. So now x is going to minus infinity, so x is a very, very large negative number. Start the same way. Erase is too big. The bottom is the same thing. So the bottom will work the same way. I'll just place one root for each there. Maybe move this a little further down. Sorry, the other way around, right? I'll put one root for both. So 25x to the 6th plus x to the 4th plus 2, all that divided by x to the 6th. So that's working the same way. But then the top, I have to be careful about something. X to the 6th, the square root of that, will not be x cubed. It will not. Take a second to absorb that. The result of a square root always needs to be positive. So for it to be positive, I have to have minus x cubed, because x is a very large negative number. So x cubed is also negative. If I said that the root was x cubed, I would be saying that the root was a negative number, which is not true. The root is a positive number. So I need to add this extra minus sign to correct the negative I already had. Again, take a second to absorb this. I'll put exclamation mark here. And then finally we have that the limit when x goes to minus infinity, pretty much the same idea, but now we have minus 10 plus 3 over x minus 8 over x cubed. So I'm changing the signs of everything. And then the bottom will be pretty much the same. Not pretty much, exactly the same we had before. And then now we can use the arguments we used. This is going to go to 0, this is going to go to 0, this is going to go to 0, this is going to go to 0. So this is just minus 10 over root 25. So that's minus 2. So now y equals 2 is another, negative 2 is another horizontal asymptote. So at the end, if you're unsure, you just have to calculate the limits.